right. Back in the shop already. Second stream of the day. Tuco is upstairs asleep in a pile of fluff, but now he's decided to join me. So, welcome back to anyone who's joining us. So earlier today I was working on assembling this circuit board, a new revision of that MOSFET glitching adapter designed to allow a processor with an internal voltage regulator to operate normally most of the time, but then within a couple nanoseconds notice to have all the power sucked out and some big inductive spikes introduced onto its power wires. And there's still various glitching strategies that we might end up approaching in the long term, but right now the strategy is to disconnect the voltage regulator's typical stabilization capacitor bank momentarily, and then to short out the processor's V-core line directly to ground, which ends up also causing some oscillations, which may or may not actually be something we want to keep, depending on how unpredictable they are and how necessary they are for actually causing the glitch to have a useful effect. So anyway, the main goals of this current board were just to make things easier to stabilize and easier to make debuggable. So it has more attention to detail in things like scope probing, but also the ground plane is nice and contiguous, and I'm paying more attention to the capacitors that I'm using and making sure to get a range of capacitors that will cover, at least some approximation of the spectrum that I care about. Searching through capacitor data sheets a bunch in the last few days, and just to see what I had in my junk drawer that actually would be applicable to this project. Although I do at some point want to go actually just make a big DigiKey order of capacitors just to have a good variety. Most of the ones that I have right now are things that I ordered for a specific project, and so the variety is accumulating, but it's not really the kind of targeted variety that I would have if I was actually ordering capacitors for variety's sake. So anyway, the main thing that happened between the last stream and this stream, besides me taking a break and no longer wanting to break this board in half, the main thing is really I organized my surface mount doodads enough to actually find the collection of parts we need to finish this. Hey, Tuco. I guess the cat wants some bolt. Maybe now's as good a time as any. Hey, Tuco. Wow, you really want that, huh? It's like way behind you, isn't it? Oh, I don't have it really hooked up properly yet, but we could take a quick look at things through this new camera that I just got that I was trying out thanks to Ken Keeter, who's in chat right now. He recommended these little HD SDI cameras from a company called Crazy Fire, which they seem to actually be pretty good little objects. I've got one over here that is currently plugged in. It's currently plugged into a monitor, but I can plug it into the streaming machine pretty easily. Alright, I don't have this actually mapped to a button on the channel changer, so I have to switch it kind of manually. It's a little out of focus. But hey, Tuco. This one has manual focus, but it does have zoom. So here I'm actually kind of zoomed in, I think all the way. And then you can probably get a better sense of where I'm holding the camera if I can zoom this out. And know, Took, I'm procrastinating playing with you. Oh, it's this one. Okay, yeah, so now you can see the wide angle view. And it actually deals with the low light much better than this little USB webcam that I have been using for TucoCam. I currently have it on a really short wire, hence the awkward angle, though. Maybe I can put this on the desk. I know, Tuco, I'm trying to balance a camera. It's a stupid thing to be doing right now. Maybe if I put it up here. Okay, anyway, by way of demoing the camera and also playing with the cat. And yeah, the low light is kind of interesting. There are a few interesting aspects to the camera. One is that it's intentionally sensitive to IR, and I have some IR light in here just coming from the lighthouse transmitters for the Vive, but I also have some IR illuminators I could fire up if I actually wanted to try that out. So we might be getting some of that. I noticed that when it gets pretty dark, it tends to see in grayscale, kind of almost like an animal would. So it's interesting. I was also noticing that in low light, it seemed like it was kind of motion blurring or averaging frames together. So I'm actually wondering if either it has some kind of internal noise reduction filter where it's doing some, interframe averaging, or possibly it has to slow down the frame rate in order to work at low light, and so maybe that's its way of kind of interpolating the signal back up to video frame rates. So I don't know quite what it's doing. But yeah, it definitely handles the low light better than pretty much any other camera I have, except for, I guess, my DSLR. So let's see. I think you might even be able to see the schematic up here. I just had this for reference so we can see what parts to put where. I don't know if it's really coming through everyone's compression, but you can actually see the first line of video is kind of weird. I think it might actually be some kind of bug in the codec. Well, not codec, but maybe even just a firmware bug. Like maybe it's giving the wrong address for some DMA buffer. Because I've noticed that, at least parts of that seem to correspond with what the sensor is seeing at the bottom. I sent Ken this video on Twitter just showing that, I think you might even be able to see here that if you can see that line at the top that I'm talking about, you might be able to see that as I move my hand, that line changes. But it's also not really a one-to-one correspondence, I think. So that might be going through some kind of transform. We might also be seeing some noise from other random stuff in memory. I don't know. Oh yeah, the wide angle is pretty neat too. I think the only other kind of wide angle shots I've seen have been from that fisheye camera I have in the printer, and that one's currently kind of hard to move. Cat. He's still just a little out of frame. Oh, there we go. This is a pretty high dynamic range kind of shot. Oh, that tripod is looking unstable. I think the bracket on the bottom of this camera is slightly not quite, I don't think it's a 1/4-20. It was close enough to put it on whatever cheap little tripod I have it sitting on at the moment, but I tried putting it on a different tripod adapter and it completely didn't fit. Oh yeah, there's a good question in chat. What camera is this? Actually I have a second one, so I can show you the camera with the camera. I think I might have already thrown out the box, but I think it was not an interesting box. Here's the actual camera. It's basically the kind of unit that you would find. I mean, it's almost like a security camera style unit, but it's kind of nicer than I would expect in a security camera, so I'm not quite sure what the intended application is, but it's a nice little unit. It's sensitive to IR. It has a zoom and a focus, but both are manual, and they have set screws to lock it in position if you want. The adjustment's pretty smooth. And then, let's see. Let me switch to the other camera to show you the back. Servo. Yeah, so this is the thing. So yeah, I got a couple of these on Ken's recommendation, and they're pretty nice. And since I just got this DeckLink card for my new video rig, it was easy to actually connect these, and they are compatible with the Blackmagic hardware, it seems. So yeah, these are pretty nice. I know a lot of us have been having conversations about making some kind of robotic camera to follow my cat around. So this is a pretty good candidate for that, since it's pretty good quality and pretty small size. The main limitation I have right now is that the cables I have right now for bringing the SDI into my capture setup are pretty short. I think the longest one I have is like 6 feet, and it's pretty thick. So I was looking at solutions for extending this, and something that seemed inexpensive and likely to work were these Balun transformers that you can get that just take the couple of gigahertz signal over coax and convert it to a differential signal that will run over Cat5 or Cat6 twisted pair. So I'm going to try that and see how it works, and ideally that would let me put a better camera in the robot closet and on some kind of robotic Tuco cam. So these adjustments are pretty smooth. Oh, I have to manually switch back to the other thing. So yeah, that's the camera that you're seeing, and that's the cat. But due to the little wire, it's probably still not quite convenient enough to use as a Tuco cam right now. This is pretty awkward. So there's back to the usual Tuco cam for the moment until I do some more wiring. Oh man, this camera is going to be just in the way for looking at the schematic, but I think that's what's next. Yeah. So I think the next pieces to put on this are probably the MOSFET drivers, and I just need to check orientation for those. That would be U4, and down here, wherever this is, U5. So that's pin 1 on the bottom left, pin 1 on the bottom right. So basically this view. I think I can get that on the microscope up at the same time. That's what I want. And maybe slightly embiggen. Yeah, I think that's readable enough. Oh, nice. Yeah, Ken reminds me that he did a review and teardown of this camera that I'm talking about on his YouTube channel, so you should search for that. And he did a good job at kind of going through all the stuff that I have only scratched the surface of. So let's see. Oh, where are we? We got some gunk there, which we'll clean off later. One thing at a time. Let's put down that first MOSFET driver. Ground myself. And just clean that area a little bit. Oh, yeah. There was something else I wanted to mention. I found a much better solution than this stupid jumper wire. Well, I didn't find a... I can't believe I don't have any 0-ohm resistors in my junk bin. I really should get some of those in my next miscellaneous thing order. But I did, for some reason, have these little doodads. Let me see if I can grab one right-handed. So this is it's normally meant to be like a contact where you'd surface mount solder the bottom, and then it would give you a place to kind of press up against a contact. I got these for experimenting with like 3D printing my own connectors and stuff. But I think if you... I cannot do this right-handed. Yeah, I should put the soldering iron away. Anyway, I thought I could stand one of these up on edge to basically give me something a little bit more like kind of a test hook, but it would actually act as a jumper, and I could use it to get across this gap in a way that is maybe a little bit more secure than the current solution. The surface tension is making it stick to my finger, but I know you can't see it because it's under the thing. Okay, well, imagine that this was rotated 90 degrees kind of toward you. But yeah, let's basically try to put that on. I think I'm just going to take off this link, which I don't think is really on there very well and is close to shorting, and clean this a little bit, and then try to sit that on there. I think with some flux, it'll just sit really nicely and I won't have to mess with it much. So let's just take that off first. Oh, I should probably have switched soldering iron tips. Anyway, this one doesn't need a small tip. The other chip I might, but I mean I didn't need one for the SC70, so I'm not going to worry about it right at the moment. Alright, cleaning. Let's go back to the bigger microscope for the moment. Oops. Microscope. Oh, this is the one that I modified. I need to unmodify this one. There we go. I was also kicking myself for not getting any raw microscope footage from the last session today, because I was going back through the stream a little bit, and some of that actually might be useful B-roll, so I was trying to get some of that now that I could use for that purpose at least. I don't know how much B-roll of that I'm going to need for this particular project, but there's this one of the other projects in my apparently too deep pipeline is the video about circuit board assembly techniques as your cat claws and purrs at you. All right. Cleans up pretty well. Flux. Oh, Tuco assumed a much more convenient spot for filming. See, now I wish I had the lower light camera, but get fluxy. Oh, there's all that flux. Ooh, yeah. Good stuff. Let's put that over here too. And mostly right here is what we want it to be. Delicious. I like the flux pen for quick stuff, but this stuff is nice because it's just like so, it's like so fluxy. It just really does the job. This might require 2 pairs of tweezers at first. Okay, so basically I want that. Thanks, soldering iron. You're the best. Okay, I consider that tacked down. Let me try to do a slightly better job on each side and see if it doesn't. Let's see if surface tension is my friend or my enemy this time. I'm happier with that. Let's just do a quick reality check here with the multimeter. Always good to have the opinion of a calibrated tool about whether I messed up or not. Cool. I think that's something I could be happy with. Alright, chip time? I think it's chip time. Which button is the thing that I want? It's this one. So, that one that is just barely obscured. Yeah, so that little guy that takes 12 volts, that's the MOSFET driver. And we can see pin 1 is bottom left, and those 2 pads that don't even really look like they exist are grounds on the top right. So, let me grab the MOSFET drivers. I don't actually have them in front of me. Oh, they are right back here. I think most of my organization this time around consisted of sorting out some of my completely unorganized surface mount parts into at least resistor, capacitor, and transistor, which is a pretty good step. And transistor also includes drivers. So LM5134. And we need 2 of these. I have like 7 of these in stock. That's great. Oh, let's not have my static strap operating in wireless mode. Alright, so there's my chippies. Let's just put those nearby their little cab. think I got flux on the top of the chip, and now that it's wet, I can't read the marking. That's a silly problem to have. Also aim this light directly into my face for some reason. Where are you, little dot? What a silly problem to have created for myself. So... oh, I guess these have a little bar on one side. That's what I'm looking for. Oh, that's a little off screen, sorry. So, if you get this in the light just right, you can see there's a raised bar on the right side, and that identifies the side with pin 1, so pin 1 would be on the left side of that one. And okay, so you can see the laser engraving is kind of illegible thanks to the... oh, there you go, you can barely see that SK7B. Thanks, Flux. See, Flux is great for metal, but it makes everything sticky and illegible, so clearly it has limited utility. This is why we don't just have Flux everywhere. That's not... oh yeah, that's right. That footprint just looks so weird without the thermal reliefs on the ground. Or, well, without that or the silk screen. The pads just kind of disappear. But yeah, that's just like quadruple checking that that's the right orientation and everything. The chips that take 12-volt power always give me pause. Yeah. Alright, I mean, just a little bit of solder off the iron is enough to make a good contact there. Heat up this big old ground plane. This part is enormous. What is this in SOT 23-6? But yeah, that's fine. So we've got one more of those to put in. This, what is that one? That's got to be a capacitor, or several capacitors. So we'll deal with that later. That is a 47 ohm resistor I put in on the gate of this MOSFET in my effort to slow it down and prevent it from causing oscillations. So that might, I suspect I'll need to adjust that, but that seems like a fine place to start. But this area over here is where the next driver goes, so that needs some cleaning. Let's also get this slightly more out of the way. Oh man, it's also possible I need to get some kind of replacement part for that camera arm. I don't even know if they sell replacement parts. Like, it's not an expensive, like a super expensive object on its own, so I don't know if they would have kits available, but it's like almost something I could get machined, but that probably would be more expensive than the actual camera thing. clean enough for now. And now we've got to have pin 1 bottom right. There it is. I'm not quite used to lining things up for the split screen yet. And these are pretty speedy little MOSFET drivers. Alright, pin 1 over there. Oh, let's put down flux first. This area is far too clean. Also not have that light pointed directly into my face. That would be awesome. Face light, got enough of that. Bloop. And a little bit of solder. Join all this flux. A little bit of solder, a little bit of cat hair, all the usual. Alright. That is plenty soldered. So I think we're mostly down to capacitors and kind of the actual output wires and maybe more ground wires if I feel like it. It's tempting to add more ground just because it really couldn't hurt, but I think that would also mostly just be stalling. Alright, I think capacitors are up next. So I did this kind of part as a compromise between kind of ideal values and the stuff that I kind of just had handy. Figured I'd use some of these. I don't really like tantalum capacitors. I try to avoid them, but I have some. I had some anyway that, you know, this seemed like an okay use for them. They don't have to be super reliable, and it's barely high voltage enough. I think I'm a little skittish about using these for the 12-volt rail because they're rated at 20 volts, but they should be totally fine for the other rails. And yeah, let's start with these. So first of all, oh man, do I have anything better for the 12-volt rail? Because I really would not like to use these quite as close to the rated voltage. These are all ceramics. I'm not going to worry about that. Just use tantalum like I was planning on. And if they, blow up or whatever, it's fine. I'm sure it'll be fine. It's not like I'm using these at high temperature or whatever. So, let's have... Was I going to use these locally to the... Just keeping track of where I'm using them because I'm noticing I only have like 4 of these. Yeah, I do have 4 of these, and my schematic has more than 4, but that's fine. I'll put them where it's most important. I think I'm just going to put a 0.1 in that spot just to have something small close to the regulator. But I'm going to mostly rely on the bulk capacitance coming in elsewhere. Because I have those two, I'm planning on putting 2 of those 4.7 microfarad like right next to the MOSFET drivers. And I think that's a better place to put them than close to the 7805. So in this spot right where the power comes in, I'm just going to put one of these 50 volt rated 0.1 microfarad 0805 caps. I would put something a little higher, but I don't have a lot that's going to be good at this voltage. So I'd rather have a small capacitor that works well at these voltages than to have something bigger that's just going to be ineffective. I'm trying not to melt the DC jack and mostly failing. The DC jack is looking a bit melty. Sorry, DC jack. Smelling melty too. Don't breathe the molten DC jack, kids. Yeah. Oops. So, okay. I've marked what I'm doing there. Let's put a couple of these tantalums over close to the FET drivers. So that would be here. Where's my PCB? Yeah. Important to check polarity, of course. So yeah, that little trace is running under all the capacitors, which is a little annoying because I'm going to have to float them up slightly, but that one on the left was going to be my largest value that I had handy, which was the 4.7 tantalum. Thanks, little iron. So, you can kind of get an eye for how much room we have. So those are the contacts on the capacitor. I don't think, they might just barely clear that without a solder mask. So I'm going to try to line it up that way, but I'm also going to float it up vertically just a bit in order to give me a little more clearance. Just since there's no solder mask, I want to make it less likely to short. You know, even if stuff flexes or, you know, if there's a little bit of debris. So let's try to actually do that thing that I just said. Let's see if we can get a side view to see how effective that was. Raise the microscope a lot. There it is. Yeah. Well, I mean, it looks like if it wasn't floating at all, that left terminal might be close to contacting the ground plane around that left side, but there's plenty of room on the right. So let's try to continue this. Oh, I got flux on my fingers and I don't even know how. I must have touched something on the board. Alright. Okay. That should be a fine little capacitor now. Let's put the other one on next to the other MOSFET driver, which would be... How did I want to arrange that? Alright, 12 volts on the right, then the capacitor goes off to the left there, which makes more sense. The ground plane there is a lot bigger than that little ground. I saw somebody in chat ask why no flux. I don't understand the question because there's flux all over the place. Yeah, there's so much flux. I mean, that like gel flux that I put down early on, it spreads out a lot when it heats up. So if it, I mean, even in some of these areas where it doesn't really look fluxy, I mean, that's why I'm getting it all over my hands. It's, in fact, this is kind of bothering me. But yeah, there's enough flux. I'll add more flux if I need to. I do recommend adding flux. It's certainly an awesome thing to do, especially if you're used to just using the amount that's in the solder. Alright, capacitor time. So let's put this in the correct orientation, otherwise we'll have some nice little fireworks. This one is easy. This one doesn't even need to float at all. else do the tantalums go? I like KiCad, but I still miss the button that Eagle has for switching back and forth between the schematic and the PCB. I keep finding myself looking for that button and then not seeing it. So, got these two. Oh, that's right. Most of them are going to be to stabilize the other two regulators, or the other regulator. So I think I'll just put the other two right here on either side of the 3.3 volt regulator. And that's the 3.3 volt regulator in a good old school TO92 case. I think I wanted to put these with positive on that square, of course, but then with ground down, because I was kind of keeping all my ground currents along that same kind of downward path. So this area is a little underfluxed. Let's don't need a bunch. A little solder on both of these. Last two of these, not especially high voltage tantalum capacitors. So it always weirds me out a bit that the stripe is positive on these. It's like the inverse of the way diodes are labeled, and I don't know why they decided to make it a different standard. Well, diodes and like traditional electrolytic capacitors are labeled with the stripe on negative. It's almost like they just wanted to see if pick-and-place operators were paying attention, because if not, then you just end up with all the boards like exploding when they turned on. Oh, was that flux or was that grease from my vise? Maybe it was flux from my vise. Anyway. Okay, done with those capacitors. What's next? We have oh, 1 microfarad, 10 volt. Do I have anything higher voltage than these? I think I can use those for the device under test stuff, but definitely not the MOSFET driver. That zoom is more sensitive than I would prefer. Anyway, you can kind of see in between giant macro zoom steps that was my plan for power supply filtering / providing current surge ability to those LM5134s. So I'm going to see if I have some higher voltage 1 microfarad caps. Oh yeah, this must be what I want. Yeah, why did I grab the 10 volt? Oh, well, because I do actually want these for later, because these are like 0603, so they might help with some of the higher frequency stuff, but because most of my caps are 0805. But this seems like a better choice for the MOSFET. And there's another ant. I wonder if that's the same one. I don't know what the ant's doing all the way over here. I don't think there's any food here. Weird. Weird little creatures. Yeah, I think I want these 10 nanofarad caps too. These are nice. I think those have... I'm kind of a fan of the Murata caps for stuff where I care about the frequency response because they have really nice data for that, whereas a lot of capacitor vendors it's kind of hard to find that. Ooh, this is a wide dielectric 0.1 mic. That's sketchy. I'm not going to use that for this. All right. So, yeah, for especially applications where you care about the frequency response, I mean, you can find plenty of videos about this on YouTube now, but you do have to pay attention to not just the value of the capacitance and not just the voltage rating, but also how the capacitance changes over the voltage rating, and also the capacitor's inductance and self-resonance will limit the effectiveness of the capacitance at higher frequencies. So that's why even just the package the capacitor is in starts to matter a lot at higher frequencies. So yeah, these I want probably a bunch of them, but let's start with 2 on the 2 MOSFET drivers. Maybe I should have put one of these up here, but like instead of that cap, but I don't think it matters. Yeah, it's gonna be nice to clean this. So down at a crazy angle. But I'm trying to hover these a little bit to avoid that middle trace, given that I don't have solder mask. And the middle trace was not an amazing thing to have there, but it satisfied my design goal for this board of trying to avoid breaking my ground plane up if I could. So I've got that. How did I want this to go? I think that's just going off to the left, right above the 4.7. And again, this one's easy. Oh, let's give that some flux. Just dip the capacitor in this puddle of flux over here. Fluxy cap. All right, where else am I going with these? I think I probably want... Oh, what did I have over here? This is where I had a place to put capacitors to attach to the device under test. And in my schematic I had a... Well, let me just scoot over because the schematic's already on the screen. was this little capacitor bank. And I mean, those values again were kind of a compromise between the spectrum that I think I wanted and what I just had on hand. So I was kind of trolling through capacitor data sheets and looking for stuff that seemed to work out. But I was kind of assuming I'd put one of those tantalums over there. Maybe I still will. Yeah. Alright, maybe I'll steal, since this is like my last 4 tantalum capacitors. Sure, maybe I'll just take this one and put it down there instead, because I think it would do a better job helping out with the stabilizing the voltage regulator. It's maybe a little overkill for that job, but... what stresses the component out more, the hot air tool or going back and forth like this. I think ideally I would have a pair of hot tweezers or something, but I don't know if I would use that enough for it to be worthwhile. Alright, let's put one of these nicer 1 microfarad caps there. Yeah, the 1 mic 50 volt. How burning is that? Oh, that's fine. It's a good, better fillet than it appeared at first glance. Alright, so now this guy, I'm going to donate this capacitor to the V-core stabilization effort. So it's going to go right over here and become C19 in that schematic. Beep. Maybe I want gel flux on that part. I mean, this capacitor is getting into the territory of being a little bit more capacitance than the chip datasheet recommends in this case, but given all the losses involved in both the extra wiring and the transistor, it seems like maybe a little bit more capacitance would be useful. And it's only slightly more. I think the datasheet recommended 4 microfarads, and I probably have a total of like 6 here. Okay. Touch that side up a little. And another 1 mic. Beep, beep, beep. Yeah, it's starting to get annoying. What else do I have handy? This is the 0603 1 microfarad. And these are 0.1s. These are 0.1s, 16 volt, 0603, X7R dielectric. Maybe this is the next choice. And we can't use these. Well, I don't want to use these for the MOSFET drivers because this is way too close to the actual working voltage, but we can use this for the low voltage stuff. The core voltage here is like 1.2 volts, so that's totally fine here. Little capacitor. Maybe I could be putting all of these way closer to that side. I'm just gonna put the other ones down and then maybe consider adding some additional 0.1s. So here are the 10 nanofarad. These are 50 volt X7R dielectric 0805 package. And then I don't even know what I was thinking with that picofarad, 50 picofarad capacitor. I don't know if that'll actually even be noticeable next to the capacitance of the MOSFET itself, but I think this might have been what I meant, the 27 picofarad that I had handy, but I'm not even going to bother with those unless I think I need something special, because I don't think that's going to have an effect. Yeah, I'm just going to put a couple of these there, the 10 nanofarad. Okay, I might end up changing this around, but that's part of why this is so spacious, so that I can easily add and remove these if I need to. Okay, so that's that. I think the major other places where missing capacitors are just on the MOSFET drivers. So like that spot and over here. So what was I planning there? That was going to be some of these. Yeah, these 10 nanofarads are good to 50 volts. And very little ant. And here are the 0.1s that are good to 50 volts. Let's put one of each of these on there. Not be using the wireless static strap. Maybe I can get us a better Tuco cam view while we're at this. Yeah, I guess the new Tuco cam with that HD SDI camera could have an infrared illuminator so that I can watch him sleep without waking him up, which hopefully isn't creepy when it's about a cat. Oh, that's right. I think the next step was going to be to just put solder down on these. Okay, so the 10 nano goes closest. Oh, and this one keeps having to hover a little bit. Well, that one has narrow enough electrodes that maybe this isn't a big deal. Alright, so a couple point ones. Now the ant is crawling toward the microscope station. Ooh, these are a little bit lighter yellow. Yeah, I think if I do that, that doesn't need to hover. For little cat hairs or whatever those are. It might even just be bits of lint from the... I don't know. Alright, and I already had this other point one out. This is getting close to done. And clean it and do a smoke test, and attach it to the device under test and see if it performs. Oh, startled by the heater coming on. Okay. Alright, let's go back to, not that, this. capacitor tune. Isopropanol. The button that makes the isopropanol splash screen show up. I think this basically just ends up liquefying the flux and just spraying it everywhere. All right, I think that's clean. You know, it would have been, at some point, nice to have standoffs for this, but I kind of assumed I would have to mount it weirdly on the device under test, so I didn't include any screw holes. Other than that, it seems all right, though. Let's maybe give this thing a little bit of wire on this port. So, my understanding, I think what I want is something that has two conductors spaced very close together. So my thought was to have two pieces of relatively heavy gauge magnet wire twisted together for a short distance. So I'm going to get some magnet wire and try to do something like that. This is not labeled. This is thicker than the normal magnet wire I use. This feels like maybe like 26 gauge or something like that, 28 gauge. I think maybe, yeah, maybe 26. Anyway, it should be fine. So I'm just going to take kind of a workable length of it here. Just cut it off. Oh geez, I have flux on my fingers again. All right, so it's tempting to do this with a power drill. Maybe I will do that. Clippy things. I need a clippy thing. Oh, the way I've done this in the past is by chucking an alligator clip into my drill. I can't find the alligator clips though. I think this is where I had them. Oh, clippy things. Where are you? Oh, I'm gonna borrow this one. Ooh, maybe I can't. Ooh, where's that? All right. I have a bunch of these little third-hand doodads that are not in amazing shape. These are the same clips I was just looking for. In fact, this one looks like maybe I've used it for something like this in the past. Anyway, so one ingredient here, some pliers or something to hold the open ends with. The other ingredient is alligator clip to hold the folded end. Alright, so I've got, how is any of this in frame? Power drill, cable. Alright, that should be enough. Alright, the alligator clip's fine. It can go back to its home in this dodgy third-hand device with only one clip. Alright, and now I have a length of this delightfully twisted magnet wire. So I'm going to cut a section out of the middle. Well, not like the actual middle, but like I'm going to cut off an end and then grab. I'm going to start with like that much, which is way more than I actually want, but I want to be able to unwrap the ends a little bit. So one end I just want to unwrap just a tiny bit. And that's what I'm going to try putting through the holes in the board after I tin it. The other end I'm going to unwrap a bit more just for testing. But then I'm going to cut it somewhat shorter when I actually solder it to my real board. Alright, so just for temporaries, I've got those unwrapped a little bit and I can tin them with the soldering iron. Let's get that under the microscope too, because it's cool. Very hard to judge depth. So you can kind of see what's going on where it's using the thermal conduction at the end to heat up the wire, but then the combination of the heat and the flux ends up kind of peeling off the insulation, which is just like a thin varnish. But depending on the particular wire you have, it could be more or less easy to burn off like this. More surefire way is to sand it off, but that takes a lot more time usually. Ew, slaggy. Let's clean that up. Yeah, maybe this is the sort of wire where I should be trimming it with a knife instead. My usual 30 gauge stuff is really easy to do this with. Seems like it's getting there. Wow, a lot of heat conducted between the two conductors. Well, let's use that as the starting point. Let's focus on the other side now. There's some brightness happening there. I think that's the extreme light that I have pointing in at the side, making the smoke glow like that, but it's pretty cool. You know, it might also just be that maybe I need more heat for this particular gauge of wire. I think that's, like, there's a bunch of that's making contact, then there's a bunch of gross slag in there. Well, that's kind of nasty, but it should be enough for me to at least check the other end after I get the other end soldered in nicely. Need to clean this slightly because it's a little too bulky to get through the hole at the moment. Does that fit? All right, I think that'll do. seems alright. So here's the opposite side. Could try to solder that to reinforce it, but I think that would make it just a pain to change if I need to take it out for debugging. So I think I'm going to avoid that. Well, no. That one. All right. Okay, that was the capacitor charging for the 12-volt rail. It's ground. 5-volt rail is not shorted. All right. Got the 50-50 luck was such that the this connector's ground, and this one should be that. Great. Okay, I think this is built. Let's see about giving it a test. Man, somewhere around here I have a barrel plug adapter that I was planning on using with this that goes to like banana plugs. Let me see if we can dig that up. Oh, I should check on the 3D printer. So far, so good. This is just printing a toy. I've been wanting to print. Somebody designed an ocarina, like the musical instrument popularized by The Legend of Zelda, and somebody made one playable. Anyway, it's been on Thingiverse for a while. I just hadn't gotten around to printing it, and something sparked my interest recently. But found the cable. So got that. And so let's just try the power supplies out first. Power consumption's nice and low, as we'd expect. It's reading between 10 milliamps and 0 on my power supply. So that is the, oops, that's hard to read. Let's try. Okay. So that's our 12-volt input. 5 volts, 3.3 volts. Cool. And our input is floating. The conditioned input is actually at 0. Capacitor bank is floating. Gate there is at 0. Gate there is high at 12.5. So this capacitor bank should be floating at the same voltage as this, which it is. And we should also be seeing that voltage over here, which we are. It looks good so far. Right. It's only an hour and a half into the stream and I already finished something. Maybe now we can actually connect this. Thought this had a place to hang out on the drill, but maybe it just wanted to hang out in the drill chuck. Alright. Oh, did I start a flame war about 3D printers? There's so much useful stuff I do with the 3D printer. I'm allowed to print toys occasionally. I've had a lot of people that are like surprised that 3D printers are useful, and then they just like see all this stuff in my shop that's 3D printed. Oh, sorry, Tuco. Okay. Okay. Alright, now I'm just thinking about how I want to physically put this all together. Oh, this board is still sticky along the edges. Like, that's where all the flux built up when I was cleaning it. I like this SMA connector on the bottom. I'm probably not going to use it right away just because right now my input is set up to come in on 0.1 headers, but you know, the bottom of this board could use a little bit of cleaning actually. There's some of that white flux residue around these pads. Alright. Alright. Okay, so I'd like this cable to ideally be as short as possible, and it has to reach basically there on the processor. There's technically another place I can get that signal, but it's so close to this clock that it's just annoying, and it's kind of under where the glue is right now. So that probably means I mean, a lot of this test setup is temporary. I think one of my next couple steps might involve replacing the chip whisperer and this FPGA with another FPGA that's doing the job of both of them. So the wooden stuff and like those boards might end up changing anyway. This is still sticky and it's driving me nuts. I wonder if that's a common problem board houses have. They make a board and the customer complains, my board is sticky. I mean, they probably have to be cleaned so much anyway that that's not going to be a concern, but I can imagine, like, you know, the solder mask isn't fully cured or something like that. That would be a pretty severe problem. Anyway, let's try not to obsess about all the flux residue. It would be convenient to not have this be completely in the way. Alright, well maybe I can sit it down kind of on top of these headers for the moment. Let's warm up the hot glue gun. A place to temporarily stick this thing. Oh, the hot glue gun, I already started it warming up because I saw this coming in advance. Great. So, what do we need to keep clear of? That's just a plain old ground. I'm going to want to put power in on this header, but I can probably put it in any of these headers. There's all of this stuff, which would be nice to steer clear of. And that might be kind of nice. This might be the least in the way place to put it, while still being reasonably close. Yeah, I'm going to pull up a schematic for, well, at least the data sheet for this chip to remind me which pins are relevant. Since I want to know where, because I know one of the pins is over here next to the capacitor that I've kind of decimated, but it'd be nice to know where the other one is. Alright, so this is the processor we've been trying to glitch this whole time. VDD-C is what we're looking for. There should be 2 of those, I think. Yeah, so the VDD-C pins are intended just to stabilize the on-chip regulator, and the datasheet tells you to connect it to a capacitor and nothing else. So that's of course where we're connecting this entire glitching apparatus. So yeah, 2 of those, 87 and 115. Alright, so that would be oh, I think the buttons on that bottom row are the ones having intermittent problems. Okay, so there's pin 1. So the VDD-C pins we're interested in are right over here, where that capacitor is having trouble, or where I repeatedly damaged the pads. And 87 right over here, yeah, in epoxy land. So it does seem like putting the glitch board physically on this side of the board might be nice. Maybe it's just time to unstick this and move it to give myself a little more room. Alright. Let's undo that. Let's undo these screws too. Whoa, there's some weird, some weird vibration coming from the walls as the train passes. Okay. So I might just kind of mount that over there or something. And then this. I don't like that. That's... Maybe I can move this FPGA. I kind of like that spot, but alright, let's keep this simple. I don't want to redesign this entire test fixture just for this one change. So let's try putting it around there. I could use a longer Ethernet cable. bigger wire. That's a silly thing to have. Yeah, a lot of stuff is going to have to change if I move that too much more. Yeah, alright, I think this is the best compromise for the moment. Just stick that there-ish, and either use a longer Ethernet cable, or this one barely reaches, I think. Should probably make a longer one. This does not seem good. You could also just start putting things down on a different base plate, but I still need some of the stuff on this one. Well, I think I know where the connection can be made and how long the wire should be, so at least I can connect these two boards, even if I'm less sure how the rest of this goes together at the moment. So I guess I want to untwist that, or just cut it. Alright, so that's the wire I've got. Should be relatively high capacitance, which for this application is actually kind of what I want. I want high capacitance, low inductance. And just to make a better connection, I'm going to sand it this time. I don't know, man. I think the knife is probably the best way to go. Just really shaving off some copper there. Well, I'm going to do this on both sides maybe, and then that plus the heat should give me plenty of this insulation removed. Bit off a little more than I wanted there. Making conductive debris. Thanks, little iron. Delicious. On the other one, it seemed to work a lot better once I had something else to solder these to. Wonder what that's up with. Alright, how am I attaching these to each other? I'm just going to temporarily stick this down with just a little bit of hot glue into this position. Okay. And I think there, I just want to kind of hot glue that right on there without shorting anything out. I mean, the only things I could short out there are these GPIO pins, so I think I'm just going to cover those with some Kapton tape, which is inexplicably not right here. I wonder if it's going to bug me that this board is upside down now. I still need to get a tape dispenser for these. Can cut off any of this I don't actually end up wanting. Okay, so there's the bottom of this board so far. I just want to put that I guess between like the second and third row of pins there. slime to that SMA jack a little bit. But that's okay. Those SMA jacks are no longer in use. Pop in a little bit of glue through there anyway. Hello, glue gun. It's kind of... Oh, this is a boundary between two glue sticks. That was the issue. Alright. Just want to hold that fairly steady. I'm also going to put some reinforcement on that side. Yeah, a couple of these more of these little standoffs. I'm just going to glue them in place since I didn't bother making screw holes. Oh yeah, so I don't know if it'll come off of the wood cleanly, but that's fine. The wood is scrap anyway. The nice thing about this, as opposed to epoxy or any of the other more respectable glues, is that it comes off of the circuit boards without leaving any residue, and without really a lot of fuss. That part's kind of neat. All right, let's try to make this a little more respectable. All right, so let's let that cool a little bit and try to install the actual V-core wires over here. Okay. So that's what's left of our circuit board. The two pins I want to use, where's my meter? Let's point those out and test them. So we have some alternatives here. So I can also get ground from, this test point over here. And then I think this via right next to the processor is what I want to go with. So there's not much copper there, but it should be relatively sturdy. Then the other signal I want is available from this test point up here, but I think I'd rather grab it from this capacitor pad. That's a little closer to the CPU. So, and then which of these is which? That one's ground. that's V-core, that's ground. So we should reverse these. This is relatively stiff wire. Multi-tweezer. Alright, so that one on the bottom should be ground. Yep. And that's V-core. So messy. Let's clean that a little bit. Getting there. Let's get all fluxy in here. That should be enough. So first I'm just going to try sticking the one to the really big pad, which is still V-core, and then I'll get that via, which I expect to be trickier. Okay. I'm gonna have to untwist this slightly more. The wire as it is now is putting a little too much stress on the board. It's a little hard to see the height difference in this microscope, but this wire on the left was also way too high up. So I think that's what we want. Let's double check that those are still the right wires. Yeah. And that's ground. And everything's covered in flux. The loops in this wire are not going to do me any favors, but I guess mechanically they might help. Come on there, solder. Looks like it's not really bonding that well to the very end of the wire, but it might just be an optical trick. I'm gonna straighten these a little bit without that attached because that looks like I'm gonna break it. Okay, I think I just made that shorter without generating conductive debris. And I think I untwisted the other wire enough for it to be useful. Let's reconnect this. Ooh, I don't like that. Maybe let's try to do the other one first. This clock wire that you probably can't see on the microscope, but it's super in the way. Yeah, I can take that off for a while. Nope, maybe I need more solder mask off of that first. There's a lot of things that could be working against me in this joint. I guess I could go right to that pad if I need to, but I'd rather stay on the via. Beep. Always be beeping. Okay, that seems more likely to work. No. Oh man. Let's try maybe tinning the ends of those wires a little less badly. I think this is helping. That's it. It's not super strong, but I think it's electrically alright. If this passes continuity, I might put a dab of hot glue on it. Turn that back on. Yeah, these really do go to two just adjacent pins, which is kind of nice. A little bit of flow there. I don't really want to scrub it. Okay. Let's dry that off a little bit. Do I still have any air pressure? That's kind of cool. I'll give it a bit of a mechanical stability boost. Okay. I think the next thing, I want to jumper over 5-volt. Yeah, okay, so 5-volt power. 5-volt power is currently set up to come from this jumper wire, which was going over here to the breadboard where my voltage regulator was, but now I can remove that. this cable was clock. Let's plug that back in. This wire, what's blue mean? Blue is 12 volts, which that's not going to be usable anymore. This is the currently overly long cable coming from the chip whisperer, which I should convert to SMA, but for now it's this current overly long thing. Green is ground, low is signal. Okay. Plug that back into the computer, maybe. I'm gonna start generating a clock soon. Yeah, that new camera is going to have a much higher frame rate than the current one in low light. That should improve the Tuco viewing. Okay, this is a bit of a nerve-wracking change to the setup at this point. I think I want these grounded through something other than just the little twisted pair there. Let's use... Sure, let's use this wire. And I don't want to use this ground, the scopes are occupying. It's not a very good ground though. Always need more grounds. I'm all the way over here, I guess I could use that. I mean, I think a lot of the pins on these expansion headers are also ground. That might be the easiest thing to do. I think they were some of these. That looks right. And 4. Yeah, let's use that. Okay. I've got a slightly more reliable power connection, so that's 5 volts and its corresponding ground. Alright, maybe we'll start applying power to this thing and start to see how it responds. I want a longer cable for this. I guess I can put these in here. Alright, so I should be able to plug this in and then see that board power on. Yep. It's that light coming on. Cool. Alright. Well, I think the next step might be turn on the oscilloscope. And what do I want? back to the chip whisperer. Drawing 50 milliamps currently. Alright, there is not actually a capture in progress. Or at least there isn't. Yeah, I have unplugged the device. Oh, that's a video. Ha ha ha. There definitely isn't a capture in progress. I mean, there might still be something going on in this VM. I guess the VM knows the scope is gone. Okay. Let's restart the Chip Whisperer software so that it generates us a clock and all that good stuff. Alright, and I'll try to plug in this Ethernet cable. A little tight. Oh yeah, start the clock. Where by that I mean load the firmware on the clocking FPGA. Okay, we have a clock. What do we have now? Do we have, oh, I need to SSH into the Raspberry Pi and set up its side of things too. Oh, I think this would be a little more reliable over Ethernet. Alright, Ethernet. Okay, link is currently down. Oh. Is it coming up? Well, let's get out the scope and see what it says about the power environment here. So, red scope probe will be, get the polarity right. Before. What are you doing, Tuco? Ow, you're so sharp. Let's turn the stuff off. Okay. Tuco, what do you want? Time, voltage. I think I don't want a measurement. I think I want their like a multimeter. Yeah, okay. I just wanted a voltage. Oh, and now it's off the edge of the screen. It's not that button. There we go. Tuco, what are you doing? It's down there going through my surface mount parts. Anyway, now you can see the whole scope and 1.18 volts. That's what I wanted. Now let's go in and see what the AC content looks like. At which point the DVM becomes useless because it no longer gets the DC content. Whatever. Tuco. Tuco. What my cat wants. Also, this waveform definitely changes when I put the processor into reset and then wake it up. I'm starting to worry that I've introduced yet another different kind of Ethernet problem into the situation. Because I'm almost, like, it looks like the board is coming back up, but like my Ethernet link is still down. Let's see what else there is to look at on here. The capacitor bank, maybe. I expect to get pretty similar AC content over there. Yeah, that's the capacitor bank. Definitely not as much of the low frequency stuff there, but it's the 12 volt power. Anyway, let's look at the clock. Don't have a good ground for that. I think I hear something on this board making sound. I can't tell whether it's like a piece of test equipment or something on my experiment. Yeah, that looks pretty ugly. Wow. Oh, was I just getting a bad contact? That's better. lot of noise on there, but I'm also not getting a great ground the way I'm probing this because there's a bunch of epoxy on that connector. Take a look at the Ethernet next. So let's just stick this over here. I feel like I don't want to get it in super deep in debugging since this doesn't seem like something that should be broken, so I'm probably doing something stupid. I'm also thinking maybe I can save the Ethernet debugging for tomorrow and just see if I can test my glitch board without getting too deep into other problems. Oh, was that just the cable not being in all the way? Ha ha ha. Speaking of doing something stupid, I think I've got a link now. Yeah. The cable at the other end that's a little off camera wasn't quite in all the way. So I think we've got an Ethernet link. I'm just going to SSH into the Pi and do a curl manually. Get this a little more spaced out. Oh. Tuco is sitting on the laptop. He might be trying to chat for me. I hope he hasn't said anything offensive. No. Yeah. Oh. Yay! I just had to poke reset. Now it's just the plain old Ethernet Heisenbug, which I still need to work on. I still have not gotten to the bottom of why sometimes when I reset this, it just doesn't get any Ethernet traffic. So I think that's the same bug we're experiencing now. But aside from that, it seems to be back to its usual working state. So we at least know the power is working. That doesn't tell us much. But I think we can actually initiate the experiment. So that's working if we run that manually. And if we go back to the chip whisperer, it's timing out. Glitch monitor. Oh, I think I'm missing my reset wire. Where's that supposed to connect? No, that's actually still connected. Okay. Well, I guess that's working. Let's see if we can get more of this on the scope so we can see what's going on. So that's going to keep doing its thing. Trigger. D9. triggers. Oh, D9 is currently not connected. Ow! Tuco, that's really sharp. Dude. Oh. This wants to be... Oh, I think I wanted... Right now it would actually be handy to have a second copy of this connector so I could plug one into the scope. I mean, ultimately I want this signal to be coming in through the SMA, and then I'll plug the scope in where that's plugged in. But I could have used a duplicate right about now. I think instead I am going to just worry about probing the MOSFET gates at the moment. So yellow and blue were my MOSFET gates before. I want to keep the color scheme going. Tuco, don't tear that up. Hey, buddy. No. Tuke, stop that. He's clawing at my floor mat. Oh, well. Cats will be cats. Okay. Yeah, that was triggering on some garbage. That's fine. I think I'm going to solve this adapter problem with two little pieces of resistor lead. So now we've got this. And I'm just going to temporarily make this into a male adapter that I can kind of stick in over here. These are a little bit loose, but I think the angle will keep them tight. What's going on, cat? Not ideal, but it'll be good enough to use that as a trigger at least. Okay, D9. There we go. Okay, now we're getting the experiment on the scope. So our pulses. MOSFET. Other MOSFET. MOSFET. No, I only have 2 MOSFETs. This one goes at the actual V-core tap. So I've definitely got too much resistance on that blue MOSFET, but you can see what a difference even 47 ohms makes. I think I had 10 on my schematic. Maybe I'll go back down to that. One more probe I wanted on the capacitor bank. Ow, Tuco, that's really sharp, buddy. Okay. Oh, man. So that's 500 millivolts. Ooh. So that's that's what happens when you don't disconnect the capacitor bank entirely, or possibly much at all. Hey Tuco, I hear you. Oh, this is good. I mean, it's not the waveform I want, but I think this board is going to be much easier to debug, and I don't see a lot of crazy oscillation like I was seeing before, which is also a good sign. So this is definitely a step in the right direction. How easy is it to swap that resistor now? Oh, that is super easy. It's right there in front. Let's see what we got. Tuco, you're sitting next to the resistors. I guess Tuco's one step ahead of me. Oh, it is getting late, isn't it? Well, I'm going to try swapping out this resistor, and then we'll see what that makes the trace look like, and then I think I'll probably call it a night. You know, drink some tea, maybe watch YouTube and go to bed. Play with the cat, of course. Hey, Tuco. Alright, let's do a little bit of modification. Oh, geez, that sounded bad. Am I going to need to take this apart again, like today? Will this lock? I guess it will. Alright. So, we're back at this little thing. So the probe, the actual probe proper, is a little bit precarious still, both because the probe is delicate and because it's not actually being grabbed onto by the socket, but the tension from the ground seems to be at least giving me a good reading, even if the setup is slightly precarious. So I think I need to get this Ethernet cable out of the way. No. Maybe not the microscope that time. This cable. Oh, I should really replace this with a longer one. Not much longer. Like, I don't want a long cable here, but this is ridiculous. Alright. Do I have any? Well, I'll look for that in a sec. Right now I'm just going to replace that resistor. So... Tuco, are you looking for a bolt, honey? Tuco, these are resistors, not bolts. Actually, they're capacitors. I lied to you. Tuco, I will throw a bolt if you bring one to me. That cat. Alright. So, yawn. Lah. Yawn. Let's take this resistor off. Let's not have this turned on. Let's turn that side off too. Alright. Alright. Did I already take out that 10 ohm resistor, or did I put it away when Tuco distracted me? Oh man, anybody who's paying attention is probably laughing at me right now. Well, I might have already taken out a 10 ohm resistor and then promptly lost it, but I guess I'll take out another one. I'm putting that back with the capacitors. That's better. I was expecting that to be on my microscope screen, but that's not the microscope. Okay. Great. Let's grab an Ethernet cable that is slightly longer than this dinky thing. This is one of those flat cables that's trying to be kind of stylish and probably... Well, it looks like it's actually still twisted wire. I don't know, maybe it's fine. I was always kind of suspicious of these. Oh, Tuco, I'll hang out with you in a sec. I want to do one more test. Alright, let's power this up. Ethernet. Alright. Huh. Well, that's not terrible. I still think it's too much. I might trade this out with either a ferrite bead or a smaller resistor still. But it does seem like this is getting in the vicinity of what I want. There's still quite a lot of spikage on that green trace, but I'm getting the blue trace closer to 0. And it still isn't oscillating, which is nice. None of that awful oscillation-y stuff. And really, the main reason to disconnect that capacitor bank is to make it easier to insert the actual glitches that I want. And it looks like those are happening pretty well. I mean, especially with the inductive kickback after the glitch. So maybe this is getting closer to something I can deal with. I mean, the oscillations seem to be gone, which is great. And that's much more relevant to me than having the blue MOSFET turn 100% of the way off. But I probably will still experiment with this more because I don't think this is as good as I can make it. But I think that wraps it up for tonight. I think I will get back to this when the day is fresh and after I've played with my cat some more. But that's the state of things. So we've finished a new glitch adapter, and so far it does seem to be an improvement. It's easier to debug, and it's got a built-in power supply, better probe points, and most importantly, it doesn't seem to oscillate. So, go gadget, less oscillation, I guess. Hey, Took. Oh, you can barely see him down there. Happy hacking, everyone. I'll see you next time. And as always, special thanks to everyone who's been supporting my stream on Patreon and with friendly words on Twitter and with gear. It's all been super helpful, and I appreciate it lots. And I'll continue to do everything I can to make the kind of content you want to see. So let me know what you want to see, and I'll try to keep edging towards something that we can all be happy with.